Then I will present the advanced architecture for future wireless networks. In the quality of service is very important in the network. We can see quality of service with a lot of parameters, latency, jitter, and so on. And depending on the application, one or another parameter should be taken into account. We can see, for example, for voice over IP, what is important is latency. For video, is very different. For example, we need more large bandwidth, and depending on the application, we take one or another. And we can see in the future, quality of service will be more and more important. We can see also the definition of different aspects of the quality of service, the class of service. We can see different classification of quality. We can see the quality of experience, which is a subjective measure of the quality. And we see that the different development of these parameters. We will see the development of the quality and the development of the device. We can see today we have a big development of Wi-Fi, of course, and the 3G, 4G, 5G, and we will see in the future that we will merge maybe in the future the different standards of the 4G, 5G, 6G tomorrow with the Wi-Fi. And we decrease, we can see the less and less connection with the cable. We have seen also in the past that we converge with a unique device, and then we can see here that today we are more and more in a common device, because in the past we have a computer is more for data, telephony is more for voice, and today we have one unique device, and we'll see that tomorrow we will be more and more one unique device. We see also development of new standard tomorrow, and we will see that if tomorrow we have only a small computer, maybe tomorrow will be this one. If you need a keyboard, that is a laser keyboard, for example, if the screen is too small, you can have a holographic screen, or you can have a OLED screen we can open, close. Then tomorrow, then your laptop will be in your pocket, and we will see the standard will go more and more in this direction to have one, your mobile phone and your laptop will be one unique device tomorrow. And also development in the core of the network. Today we will see the big development of optical switching. And here we can see that it's not necessary to go to optical, to electrical, to have switching, and to return to optical. We can have full optical, of course. You can see a very small mirror, and with a small motor, and automatically the laser are switched automatically. Then we can see there's a new device, new technology appear in the core of the network. Of course, the optical fiber looking more and more closer to the final user. We can see today we have fiber to the home, and tomorrow fiber to the terminal. We can have closer and closer to the end user. To have this quality of service, we have a different standard, and quickly a few words. You can MPLS, INTSERV, RSVP, DIFSERV, all these standards are used today to offer quality of service in the networks. We have seen the development of the technology in the past. In the past, we have ETM. If you want quality of service, ETM was a good technology in the past. After, we have IP over ETM. After, we have ETM has been disappeared. And the new standard is IP over Ethernet, and tomorrow IP directly over WDM, wide division multiplexing. Then that is the technology in the core of the network. And what about optical or wireless networks? In wireless network, we can see there is a lot of standard, big evolution for 1G, 2G, 3G, 4G, 5G. And all this technology present new characteristics. And of course, also 6G tomorrow, there will be beginning development about tactical internet with massive data rate, massive low latency, massive reliability, deployment with resilience against jamming, massive scalability, massive security, because security is very important, and massive rural coverage. And we will see what will be this new standard which will appear. We see also that for all this wireless network, we can have a global internet connection through satellite, geostationary Earth orbit, medium Earth orbit, low Earth orbit, with 5G, with LTE, 3G, 2G. There is a lot of standard, and each multimedia mobile application will create a common platform which incorporates different services, and we will see the quality is different depending the network which is used. Then for the quality of service in this wireless network, there is new characteristic, which is prime is a battery. Then today we can see development of new generation supercondensator battery or hydrogen battery tomorrow, and should be development that we can see. For example, Apple working on this. There is some patent on the hydrogen battery tomorrow. And each wireless network offer different quality of service, of course. Then if for connection, we can have a radio electrical connection or infrared connection, no more use because with prime with the penetration of building, microwave, but do not penetrate building, light wave with a laser connection between different buildings, maybe it's a good solution sometime if you. But of course, either with raining or snow, of course, the communication is disturbed. And today, we can see development of light fidelity. Then, if you have in our environment, there is no, for the hospital, we cannot wave. Then the internet connection can be transmitted through through the light. Then we can do. With light, we can transmit the internet connectivity. Then in some school or hospital, maybe it's a solution also for security reasons, because if you are here, maybe the Wi-Fi can go outside of the building, but with the light leafy, it stay only in the room. It cannot go outside. Then we have a multi-technology access. We can see for 1G, the technology is FDMR. For 2G, TDMR, time division multiple access. For 3G, CDMA, code division multiple access. For 4G, OFDM. We can see other technology for 5G with OFDM, LTU, and so on. Then for all this communication, we can see if you want a global communication today is possible, and it's used today in a lot of applications. For example, for communication with LEO, low Earth orbit, today is very used. For example, in airplane, you can see you have internet. Of course, the only solution is connection with LEO, MEO, medium Earth orbit, geostationary Earth orbit, and we will see also development today of VLEO, very low Earth orbit. We will see in the next slide. Then today we can see for all this communication, people want a large bandwidth, and the solution will be use high frequency. You can see you can V-band with 50 to gigahertz for future big communication, because more higher is the frequency, more transmission of data you can do. We can see for this application for LEO, we have for both satellite is between 500 to 2,000 kilometers. Delay is very short, and to cover all the world, 50 satellites are enough. And we can see the satellite during 50 minutes, and just a lot of time. So a lot of projects. We can see Iridium, Global Star, OneWeb today is a standard which is a big development today, and for 2020, and a lot of airplanes will be connected with this platform on OneWeb. MEO is a higher altitude, and you have located at 5,000 to 20,000 kilometers. Delay is more important, of course, and then you can see the satellite in 1 hour. Then 12 satellites are enough to cover the Earth. And the major standard, of course, is GPS, Global Positioning System. if you go higher, you have a geostationary Earth orbit, and then the delay is more important. The altitude is 600 kilometers. Duration is very important, and then you have this system is no more used for telephony, of course, because you can see the size of the antenna is not a good solution, but it's only can be used only for TV, meteo aspect, and so on. And what about today? Today we can see development of new generation. We see more focus on the pico satellite with development of HAPS, height, altitude stratospheric platform. And there is different projects today. We can see the Proteus airplane, airship with altitude on 23 kilometers. And we cite, of course, the Google Loon project. Then we will try to cover area in the world with, for example, Africa, with no other solution for connectivity to internet. Then the only solution in this case is through the air, because there is no infrastructure to to have an internet connection. And then you can see the Loon project, Google Loon project. You can see one laptop per student. You can see here, because in this country, people have no electricity. Then to create electricity, you can, if you have no solar center, you can create by yourself. And here you have the drone to have a connection without drone, without pilot, and it can be used for connection automatically. You use solar sensor to refuel the battery during the night, and it can fly. Then we can see to communication, we can have different sites of cell depending on the population. If you have very few people, you can have macro cell, 10 kilometers. More people, micro cell, and a lot of people are connected. Then a picocell or femtocell, the size are very small. You can see 5 meters to 50 meters. And there is a lot of standard today. We can see for 2G, 2.5G, 3G. There is a lot of standard depending Europe, Asia, America. All these countries have different standards, and we try to converge to one unique standard maybe in the future. We can see, for example, for 2.5G, the standard which will be GPRS, General Packet Radio Service. The rate is 48 kilobits per second, very, very slow. And 2.5G, the standard, of course, is EDGE, Enhanced Data Rate for GMS. The rate is 155 kilobits. We have also enhanced GPRS. After other standards appear, you can see standard 3.5G with HSDPR, which offer a rate of 4 megabytes. 3G, of course, is UMTS with 384 kilobytes. We can see 3.75G, 6 megabytes with HSUPA, 3.9G with LTE, 4G with LTE, and 5G with a new standard, which will be offered which appear today. Is a standard will be 50 gigabytes per second LTE, and it can be used for virtualization and cloud data center IoT. That is utilization for this 5G standard. And what about the new standard will be, of course, after 5G plus 1 to 3 terabytes per second, and we can see very big bandwidth. And the consumption, the latency will be very low, comparing low latency. Reliability, very important. Positioning 130 meters, and can be used, the standard can be used for augmented reality, virtual reality, and what is the utilization in the future. And what is the need of 5G, of course, is very important for connected device. We can see today all will be connected. The cars, a lot of devices in the life are connected, need to be connected, and for Internet of Things, it will be affordable, sustainable standard with good low latency, reliability, low price, data rate, which will be very important. And we will see the traffic for this Internet of Things will be more and more important in the tomorrow. Growing. Then if you see the difference for 5G, for 4G to 5G, we will see the development of virtual reality, A lot of standards are developed today. We have more connection, more mobility. We can see a lot of consumption energy, very low consumption energy, massive reliability, low latency, large throughput. And we will see that with a lot of mobility, we will be connected every time, everywhere. And the development of a lot of Internet of Things, a lot of objects will be connected. Then for 5G, then will be people want to have a millimeter wave technology, hotspot system for high data speed, higher capacity, shorter coverage, massive MIMO, of course, will be overlaid with 4G because people will be using two technology during the same time, and broader spectrum bandwidth with higher frequency spectrum. Then all this technology are developed, of course, for for development of Internet of Things, because it will be very important for, we can see for car, electrical device. We incorporate additional information for different, we can see for parking meter, traffic light, all will be connected through Internet of Things. And there is a lot of standard. We can see different standards. First of all, Sigfox can be used in this case. And we will see the development of other technology, for example, the fog computing, the cloud for Internet of Things, that it will be devoted for this technology. And development of software-defined mechanical system. Then we can see the development of in the cloud. For the cloud, we can see here. You can see the cloud system with SaaS, PaaS, and IaaS, infrastructure as a system, platform as a system, and service as a system. And we can see today development of MEC, mobile edge controller. We can see the control plane is distributed to local controller, like for example for telecommunication. Then we go for centralization of the system to our decentralization of the data center. And if we continue, we go to after the MEC, we go to the fog computing. Then the control plane is distributed more in the equipment, in smaller equipment, like for Internet of Things. Then we can see for local management video for those devices. And if we continue, we can have development for fog system. After fog system, we have the skin system, the femto system data center, and that is development. We have a virtual Wi-Fi, virtual controller, and we can apply for all our devices like Google Home, Amazon Echo, Google Mesh, and so on. And then we can see initially we have data center are centralized and more decentralized, and we can see a virtualization of the networks, and it go more and more and the end user with very small data center through the development of the skin data center. Then development also of SDN, which appear new system which appear today with development of SDN product with SD-WAN, vCPU, Cloud RAN, and a lot of different software exists to the Open Computer Project, DPDK, Docker, UDP, and so on. And then we can see all this, for this system, we can see the separation between the data and the control plane. And the data and control plane are completely separate. And we have a new system, new control system for the cloud with the development of this technology for the MEC, the fog, the skin, I described here. And we see a strong computation to determine the path and for development of this new infrastructure. Then for Internet of Things, we have the very big development with massive MIMO, development with advanced cloud radio access system and so on. And for we will see development of ultra reliable, low latency communication, and with this 5G system, of course, is used for this IoT communication. But 5G is not the unique solution. You can use Bluetooth, LTE, Zigbee, presented yesterday, Sigfox, Wi-Fi, and so on. But we will see more and more 5G maybe will be more and more used in the future. That is a tendency. And for Internet of Things, you have the other project here you can see which can be used for LAN, Sigfox, LoRa, of course, it can be used also, and other projects. Then 5G tactile internet will be enabled for remote skill sets and delivery with low latency, which is important, high security, and high availability. And then we can be used for development of haptic virtual environment in this case. That is development for 5G, 6G system. And what about the other system for the IEEE 802 standard? You can see the standard is 802.15 with the wireless personal area networks. 11, the other is 11 with the wireless local area network, 16 with the wireless metropolitan area networks, and 802.22 wireless regional area network. Then we can see there is not one single technology, but a family of complementary technology with different quality. That is important. Then quickly a few words about wireless personal area network with WPAN is a standard 802.15. Then the different available product today is the wireless USB, Zigbee, we can see, and of course Bluetooth, which is one of good standard, RFID, NFC. You can see a lot of very famous standard which is in this classification. If we go in the wireless local area networks, wireless LAN, then the different standard everybody knows is 802.11b, G, A, I for security, end over N with the Premimo. Today we are more here. And we can see, depending on the size of the network, you have different standards. For example, here you have 11EF, because a very low very large distance, but the bandwidth is very low. And here you have the EH, BGN, that is a house. And if you have very high need of communication, very big, for example, transfer of big video, something like that, big size. If you want a big bandwidth, you can use 11ED, for example, here. Then we can see a lot of different standards today existing today. We can see EH with low frequency, low consumption, but 1 kilometer. Then for small grid, but very slow. EF for cognitive radio. EC beam forwarding, AD you can see for very high throughput, 60 gigahertz. You can have with WGIG, wireless gigabit alliance, 6 gigabyte for communication. AIX for tomorrow, you have communication for 10 gigabyte per second, and AEA will be 40 gigabyte for communication. Then you can see a lot of different standards. If you continue to increase, we enter the wireless metropolitan area networks, then we have WiMAX, but today it's no more used because it had been replaced by 5G and 5G, 4G system. Then this standard is no more used today. Then 802.21 is also devoted for handoff among different network and different type of networks. You can see we can have Wi-Fi, WiMAX, cellular networks, and we love different solutions. And all this system can work together to have a complementary network technology to deliver data, which is originally targeted only for cellular networks. Then to conclude, we go to the next generation of internet. We will see tomorrow one unique network with wireless data, voice, TV, all this technology will use tomorrow, one unique network. But there is still a lot of problems which should be solved. Today, for example, consumption is very important because people want green networks, and problem of TCP/IP. TCP is very complex, consumes a lot of energy. Maybe a new TCP should be created tomorrow. We will see IPv6 tomorrow will be used more and more in the future. We will intelligence on the network with small, active, autonomous networks with auto-configuration. We have seen the development of virtual internet with cloud data center today, and the development of virtualization, then we have development of SDN, software-defined networks, NFV network functional virtualization, NDN tomorrow. Then internet will be more, today is based on the address, tomorrow maybe internet will be more based on name. You will not, maybe you no more use IP address, but for example, restaurant, then more address, name, data networking. Also development of Internet of Things, presented previously, of big data, and that is very important, the wealth of the data. And development of, we have seen the development of decentralization with a skin network, with a MEC network, with a fog network. And for all this network, we go for software virtualization. We go to a hardware virtualization because it consumes a lot of energy. Then other solution will be maybe tomorrow centralization. Then we are going from hardware networks. Today we go to a software networks more and more with a concrete software network which permits any kind of mission which is optimally based on cloud network and distributed to data center to support different smart networking provisioning. Then maybe tomorrow we will more and more see the Uberization of the networks. And everybody has his own personalized network. And we will see today with the 5G, with a slice by network or by application, then you have very, we can see the standard of the 5G, the development of slice of networks. And of course, security tomorrow is a very important topic because security is very important in the next generation of network, especially for 5G, 6G networks also. And what other topics which is for tomorrow is the convergence of 6G tomorrow in the next 10 years with Wi-Fi. Maybe we will have maybe one unique network, not 6G and Wi-Fi, one unique network tomorrow, which we expect maybe to have a convergence of this 6G and Wi-Fi tomorrow. And also maybe development of VLEO, very low Earth orbit. We have seen today development of low Earth orbit, but tomorrow maybe very low Earth orbit. And we can see the price is not very more cheaper than 6G and Wi-Fi tomorrow, maybe. We don't know which solution will be used. And also connected with the connected thing to connected intelligence, which is tomorrow development of IA and machine learning. It will be very important and maybe will be integrated in the networks, in the software networks. Okay.
All right, thank you very much, Professor Pascal Lawrence. Join me on stage.